Hello everyone, I'm Sam. This is my final presentation for MEMS 5001, and my final project is jet engine optimization. Here's a summary for my final project. So the goal is to try to maximize both the propulsive efficiency and the thrust of a specific jet engine during the process of taking off. So the method that I'm going to use is genetic algorithm. An introduction to the background. So a higher acceleration rate would result in a higher fuel consumption. So my goal is to achieve necessary thrust without ruining the efficiency of the jet engine. Here is a plot of the jet engine. So I will be focusing on the analysis for the combustion chamber, which is the part between 2 and 3. The equation for the thrust is as shown, and the propulsive efficiency is shown here. I want to talk briefly about why I want to do this optimization. So in order to get better thrust and also better efficiency, we can just increase the temperature tolerance in the jet engine, but we have to redesign everything, and the process of that is costly and also time consuming. So instead of redesigning everything, I will be focusing on a more efficient way to drive the airplane. So I'm gonna simulate a way to drive the airplane to get better efficiency and also better thrust. Here are the assumptions that I made during the calculation process. So to set up the optimization problem, I want to talk briefly about my design variables and my constraints and also the cost function. The design variable in my project is the theoretical percentage of air. So this basically simulates the process of using accelerator or the throttle in the jet engine. So if the percentage of air goes down, that means that the amount of fuel injected goes up, which means that the accelerator is being pushed harder. Here are the 3 constraints that I have for this project. The most important part of my optimization project is to construct the cost function. In my project, there's a multi-criterion process, so I have to maximize both efficiency and the thrust. So firstly, I normalize both of the criterions, and then I construct a better cost function by reversing one of them. So the construction of the cost function, including the analysis for diffuser and compressor, also turbine, and also nozzle. The most important part of my cost function is the analysis of a combustion chamber. So I use adiabatic process to analyze the combustion chamber. Here are the results that I got from my optimization. I don't intend to use Excel, but it's just gonna save a lot of time because while running the MATLAB code, I can do the analysis in Excel because each of the data points on the graph there takes about 10 minutes to get it. So I just want to save time so that I use Excel. So the number that you can see at the bottom of the graph is 0, 5, 6, 7, 8, 9, and infinity means how important you value the efficiency. So for 0, you don't care about efficiency at all, which gives you a really low percentage of air, means that you are pushing a lot of fuel into the system so that you can have a really high thrust. So for the line on the top there, it has a coefficient of infinity, which means that you really care about the efficiency. So you can tell that the percentage of air is really high. And Therefore, it kind of makes sense that you are not using as much fuel as when you don't really care about efficiency. My future plan is to focusing on simplifying my cost function so that I can use less time to get more data points and to do like better analysis after that. Thank you for watching.